Alright, these last couple that we're going to work are real doozies. And what happens here is we're going to have a right triangle and we're going to have an altitude. So that is something that goes from a vertex and is perpendicular to the opposite side from the right angle of that largest right triangle. And when you have that altitude, it divides this into two smaller right triangles, and all of those triangles are similar to each other. So by drawing this line, we've now created three similar triangles all in the same space. And so it can very quickly become a headache trying to keep track of all of them. So let's look at this one first, and then we're going to take apart some of this and see what it means. We're given this leg of the big outer right triangle, and then we're given these two pieces, which all together, if we add both of those, give us the length of the hypotenuse of that outermost triangle. And here's what we can do, is we can use a couple relationships that are set up in this, and I would highly recommend that you memorize these. But you can look at a couple formulas, I guess, that'll help you remember exactly how to do this. Right, here's the first one of those, and I'm going to write it in kind of shorthand here. Hypotenuse over leg equals leg over side. And there's all kinds of crazy interesting things that happen from this. Alright, so first let's talk about terminology. When I say hypotenuse and leg, I mean of the big triangle. So here the big triangle is this one right here. So the hypotenuse of that would be 25, and then the leg that we know about would be x. This leg is still that same leg x, but this side right here is actually any side of the smaller triangle that includes that leg. So here we can say 9 for that one. So it's the side that is included on that leg. What this means is that leg is what we call the geometric mean. Just like you can take the average or the mean arithmetically, add a bunch of things up and then divide by how many there were. If you do a similar thing but with multiplication and then taking a root instead of dividing, you get what's called a geometric mean, and this leg turns out to be the geometric mean of the hypotenuse and that side. Now, less distracting, I guess we could say, is we could just solve this. We now know our hypotenuse is 25, our leg is x, this leg is going to be x as well, and this side is 9, so that's the side over here. So that tells us that x squared is going to be 25 times 9, which is 225. Now we're tasked with finding what x is. To undo squaring something, you'll recall from algebra, we take its square root. And so the square root of x squared is x, and the square root of 225 is 15. Now, technically speaking, x could be positive or negative 15, but you're not going to have a negative side length. So x, in this case, is going to be 15. Alright, so this is this situation. If you have the leg of the outermost triangle, it's the hypotenuse over the leg equals the leg over the side that includes that leg. Alright, now let's look at one where we have the altitude itself is the unknown. And when we have the altitude being the unknown, we have this neat situation. I'm going to give these names up here just so that we can more easily see them. I'm going to say that the altitude rather is A. I'm going to call this side B and this side C. And interestingly enough, from the information we're given here, we know how long C is. If this is 16 and that entire thing is 25, then C must be 9. So I can go ahead and fill in that information. We know it from the diagram. So the situation that comes up here is, we're going to call it side 1 over, not the hypotenuse, but rather the altitude, sorry, that's twice I've done that now, is equal to the altitude divided by side 2. And side 1, we're going to say is B, so we can say B over A equals A over C. So this would be side 1 and side 2. So that altitude is the geometric mean of these two parts right here. And so if I substitute in those numbers, we can find out what that would be. Side 1 I'll call 16. My altitude is so we'll call it x. The altitude is still so we'll call it x again. And then side 2 would be 9. Now when we solve this, we're going to get the same situation. X squared is 16 times 9. We're just cross multiplying there. Take the square root of both sides, and we find that x will be 12. So the altitude of that triangle would be 12. And so again, I highly recommend that you take these and memorize them, and the situation that they go with, it will come in very handy.